Hello and welcome to the Math Studio. In this video, we're going to look at a more complicated example involving products to sums. So let's have a look at the example. Now, just to save some time, I've pre-written the solution, but I'm going to step through the solution with you to help your understanding. So let's have a look at the example. Express sine of 20 degrees, sine of 40 degrees, sine of 60 degrees. So sine 20 times sine 40 times sine 60 as a sum or difference of trigonometric ratios. So what we're going to do, we're going to basically group sine 40 and sine 60 together in a separate sort of set of brackets there. That's what the square brackets are for. And we're just going to leave sine 20 out, sort of on the outside. Now you could have alternatively grouped the sine 20 and the sine 40 together, sort of put a bracket around that and sort of done the same thing, and you should end up with the same result. So our first line will be sine of 20 degrees outside of sine 40, sine 60. Okay. Now, sine 40, sine 60, that's a sine-sine case. So we can use the difference of the cosine ratio. So this is half cos of 60 minus 40 minus cos of 60 plus 40. And of course, don't forget that there's sine 20 still on the outside. Okay, so if you're unsure where that one comes from, you could look at one of my previous videos where I do an example involving a sine-sine case and expressing that as a sum or difference of cosines. So just simplifying what's in the brackets, so we've got 60 minus 40, and that's going to be 20 degrees. 60 plus 40, there's 100 degrees there. So we end up with half sine 20 degrees outside of cos of 20 minus cos of 100. Now what we can do is leave the half on the outside and then multiply through the sine 20. So we end up with half outside of sine 20 cos 20, so that sine and cos get multiplied together, and also the sine 20 multiplied by negative cos of 100 also appears there as well. So just to make it again just a little bit easier to read, I haven't expressed the angles inside brackets, just to sort of minimize the amount of symbols that I'm using. Hopefully that's a little bit easier to read. So let's have a look at this line here. So you notice that we have a sine 20 cos 20. That's a sine A cos A case. Now if you recall, sine A cos A or sine alpha cos alpha, or two of those, 2 sine alpha cos alpha is equal to sine of 2 alpha. So what that means is that if we make sine alpha cos alpha the subject of the formula, so sine alpha cos of alpha, that's equal to sine of 2 alpha all over 2. And that's where the sine of 40 on 2 comes from. So it just comes from that there. So we have half of sine 40 on 2. So that sort of takes care of this part of the expression. But then we have a negative sine 20 cos 100. So this is a sine A cos B case. Okay? So a sine A cos B case can be expressed as a difference of sines. So hopefully, sorry, there's a bit of a reflection there. Okay, move that over just a bit. Yep. So that's a difference of sines. So we end up with, okay, so I'll just go back over this line again. We have half times sine of 40 on 2 minus half sine 20 cos 100. Now this line here, so I'll just move the board up just a touch. Okay, so we have 1/4 times sine of 40. Okay, so half, 2 times 2 is 4 there. So 1/4 sine of 40 minus half outside of, now this is where just got to be just mindful here of the use of brackets and just keeping the algebra neat and tidy. So we have half outside of sine of 20 plus 100 minus sine of 20 minus 100. So that's using this point here, the 2 sine alpha cos beta is equal to sine alpha minus alpha plus beta, sorry, minus sine of alpha minus beta. So if we divide both sides by 2, that's where that half comes from. So that 2 there becomes half on this side here. So dividing it by 2. Now again, let's simplify what we can. So we end up with 1/4 sine 40. So that hasn't changed. Minus, now we have a quarter. So half times a half gives you a quarter. And we have sine of 20 plus 100, that's sine of 120. So that's a quadrant 2 angle, and that's an exact ratio as well. So hopefully you can recognize that, and if you see a sine of 120 or sine of 100, so sine of 60, they're going to be equivalent in terms of the ratio. Minus 1/4 sine of negative 80. Okay, so that half times half multiplies all of this. Okay, so if you look at the brackets carefully, you'll see that it's 1/4 times everything. Now, sine of negative 80, recall that sine is an odd function. So that negative 80, that negative can come out to the front. So we can express sine in terms of a positive angle. And then we have a minus minus, which turns it into a plus. So what we end up with is, so actually let's go back to the original expression. Sine of 20, sine 40, sine 60 is equal to, or equivalent to, 1/4 sine 40 minus root 3 on 8. Now recall sine of 120 is root 3 on 2. So I might just make a point of that here. So that's, okay, so that's square root of 3 on 2, which you multiply that by 1/4, you get root 3 on 8. And of course, plus 1/4 sine of 80 degrees. Okay, so if you want to check with your calculator, you can evaluate this expression here. You could also evaluate sine 20, sine 40, sine 60, and you should find that at least from a calculator's perspective, the decimal result should be the same. Thank you for watching.